So I'm going to give you a presentation of CompatibleOne, which is an open source project. It targets cloud computing, and it develops new technology. It really is innovative, and I invite you to join the mailing list. So first of all, let's have a look at the cloud computing environment and where CompatibleOne fits in this environment. First of all, we recognize that there is a new wave of technology innovation that we call cloud computing. Cloud computing was maybe identified as a marketing fad, but after a few years we realized that it's a real big trend, and it's probably the form that what we used to call utility computing is going to, utility computing is going to happen in the form of cloud computing, really. But what we see is that cloud computing architectures today require lots of innovations. On the other hand, these innovations for us, from this standpoint, from Faisal, have to be open source. And we recognize that cloud computing may pose some sort of challenge for open source software, because we define open source in terms of our ability to access the software. However, with cloud computing, the software is behind the services, and we have to define what is an open source service, for instance. So we take the problem step by step, and we evaluate that we are looking at open cloud computing, and that for us, open cloud computing requires open source. And we'll see later how we can define that. This is something we are undertaking in the context of CompatibleOne. So that's what we do at OW2. We try to foster open source for open cloud. And when you look at this, the environment, I'm not going to read this, but you can recognize many projects, and you can see that cloud computing innovation today is driven by open source. And all these open source projects are today defining what cloud computing will be. Why? Simply because collaborative innovation is a way to accelerate the process and to make the new technology happen quickly. Now, it happens so quickly that you all remember that simple diagram. Cloud computing used to be defined in terms of infrastructure as a service, platform as a service, and software as a service. But now, and that was like 3 years ago, and so last year, the National Institute of Science of Software Technology in Science Technology in North America, which kind of issues the reference model, came out with this model where you realize that the 3-layer model is in fact buried inside a very complex and more global, broad scope. So there are many opportunities for innovation out there. And what we have today in cloud computing, when you think of virtual machines, management of virtual machines, distributed file systems, this is very low level. The administration of machines, this is very, very low level. All this eventually will be commoditized and will be automated. The real value and the real innovations will happen in the upper layers. And we think that there is a whole window of opportunity being wide open now, and that the new technologies will happen and will be developed within the next 5 years. So today, what we have is a cloud computing environment where interoperability is not provided. A cloud computing environment where portability is much, much more difficult, where we don't even have mature standards, and where, in fact, interoperability will be provided not by the technology itself, but by third-party technology, something that we may call the cloud service brokers, and that's what we're going to talk about. Today, we are in a very dangerous environment where cloud computing is kind of replicating the limitations of proprietary software. We may have interoperability, but within silos. We may have flexibility, but within within the perimeter of the technologies of one vendor. So it means that the risk is to go towards new vendor lock-in and loss of freedom and control of the users. So let's have a look at that technology that has been identified by a number of analysts that we call the open source or the cloud broker. And CompatibleOne precisely is what we try to call the open source cloud broker. Where do you get the information? Here you can have the resources. First of all, you have the NIST white paper that was issued last September. Second, you've had Gartner and Forrester Research publications that analyze extensively the role and the opportunity of the cloud broker. Specifically, Forrester and Gartner have identified that the cloud computing market, specifically at this segment, if we can identify the broker as a segment, is going to be a multi-billion-dollar market. So let's have a look at this environment. The reference architecture provided by the NIST identifies different roles. So it's not now only a DevOps type of challenge, cloud computing, but it's something where you have what they call the cloud consumer, where you have the cloud provider and the cloud auditor. Because of course, in terms of services, you always have to check that the service that is actually delivered is the service that was expected, the service that was contracted for, the service that was invoiced for. And this is something that is absolutely strategic, because you cannot have a service economy without having the ability to verify that the service is actually well delivered. And all these different roles maintain between each other different kind of connection. This is an intellectual model. Now we have to make it happen, and that's what we try to do. In terms of industrial challenges, this is analysis by Forrester Research, and they identify who are the stakeholders in the cloud ecosystem. It's a whole ecosystem, so we here in the technology conference, but we understand it's not just about technology, it's about power play between administrations and between vendors. And here we can identify different kind of vendors. Those that come from the software, those that come from the service, and then you have the infrastructure providers, where you find all the telco operators. So you recognize in those names, in those to the left of the slide, you recognize names that come from the old computing and new names. Why? Because the new wave of technology always translates into the emergence of new vendors and a reconsideration of what competition is about. And interestingly enough, what you see in the middle of this graph, you see what? The broker. The broker is the place where the different roles will interact, will be synchronized, and this is where the key strategic opportunity resides. So what are the key roles of the broker? Well, we identify, or the NIST has defined it into 3 roles, which are very interesting, in fact. The broker provides service intermediations. It provides to a service consumer services that are provided by somebody that the consumer does not see or does not directly connect with. That's intermediation. In doing that, the broker may add some value, maybe some security services, or maybe some SLA measurement services on top of that. So in wrapping this service, in the intermediation, the broker adds value. Second role, the broker aggregates services. It addresses the needs of an end user by selecting different kind of services, aggregating these services, and delivering them to the user. And last but not least, the broker has an arbitrage role. The broker selects the services depending on the constraints or the specificities of the needs of the consumer. That's another way to add value. So you see there is a great opportunity for adding value. And what we have here is a role that we know in day-to-day life. Think of an insurance agent. think of a travel agent. So the travel agent, what does it do? You want to go on holiday somewhere, you need a plane ticket, you need to rent a car, you need a hotel, maybe you want a ticket for a show. You go to the travel agent, they find the plane, car, hotel, and show matching your expectations, your needs. Maybe at some point they suggest a selection, an option, they put everything together, and they give you a package, and you can go on holiday. Basically, transferred into the cloud computing world, that's in very simplified way what the cloud broker will do. It will provide a single, consistent interface to multiple differing providers, whether the interface is for business or technical purposes. The last words are very important. The broker provides technical services. It finds resources that the consumer cannot find really, and it finds them with the right economic conditions to optimize the value delivered to the user. That's the role of the broker. Now, where does our project fit? And the CompatibleOne project is a community endeavor. So it fits within the framework of the OW2 community. We are a global open source organization. Our mission is to develop a code base of open source middleware infrastructure software. And because we also recognize that open source is not a good way to develop software, but also an interesting business model, the second leg of our mission is to help our members develop a business ecosystem. And that's what we're doing here. When you can see our booth on the exhibition floor, where we have 4 of our members exhibiting, teaming together in order to make this business ecosystem happen. We have 70 members. We were created out of Europe. We're growing in China and Brazil, and we also have some traction from North America. The project fits within what we call the open source cloudware initiative. It's a collective effort by members to put together existing projects or to develop innovative technologies in order to position themselves and to position the organization on the cloud computing market. It combines different kind of projects, the OW2 project, of course, existing projects, but we also invite third-party projects to join, or we also leverage third-party projects, of course, because we don't pretend to develop the whole catalog of required technologies for cloud computing. And we also get ourselves organized into proactive, collaborative projects that are projects where we define a plan, what we want to do, and we get the financing and the people together and the work plan together. CompatibleOne is one of those projects. The Open Source Cloudware Initiative today has over 30 members participating in it and coordinates over 60 million euro in R&D investment. No marketing, R&D investment, 60 million euro in R&D investments. Quickly, we have one project called Open Cloudware, which is developing a platform for managing the application lifecycle over the cloud. Another project is called Excel Cloud. It aims at developing a platform for managing distributed virtual machines with high-performance computing targets. All these projects have over 10 participants in them. Coreos is one project that aims at developing a platform for the management of web services in an ultra-large scale environment, typically targeting the Internet of Things type of applications that will, of course, run on cloud computing platforms. And, of course, CompatibleOne, which really aims at developing technologies that will provide real interoperability and freedom for the end users. So let's have a look at this program. I think I have to accelerate. It's an open source program. Open source project means that although some companies get funded for that, everything is published, everything is open, and you're welcome to join in, to subscribe to the mailing list, to give your opinion, and if they grant you writing access, you can contribute to the code. It is open. We want to really push it across the industry, and we already have, today there are a good 30, 40 developers working on it, coming from a dozen of organizations, some of them large organizations, some of them small innovative companies, some addressing security issues, some applications, some processing issues, etc. We also have research institutes in there, and the project was started 2 years ago and will be finalized in December 2012, and we will be launching it in November at the Cloud Expo West in Santa Clara in California. What we aim at with CompatibleOne is comply with what we understand as freedom in the cloud computing environment. That is the right or the freedom to choose your cloud providers, to use any kind of hardware or software you want. So you got to have that kind of choice. To control your infrastructure and your applications, to know where your applications run, where your data is located. To distribute your services between public, private, and service clouds, so you can reallocate your resources the way you like. You have no constraint on this front. To move your applications where you want and when you want, and to adapt the code, and that's an issue, to adapt the code to your needs. So you need to have access to the code. There is no open cloud for us if there is no publication of the code somewhere. So eventually, you will be able, with all this, to control the security and the quality of service. This, for us, is the charter for open cloud and for freedom on the cloud. With CompatibleOne, we have, so that was the idealistic approach, and now let's look at the bottom-up approach. We've started from use cases. We took a number of use cases to see how and what were the requirements, what were the services that we needed to develop and provide in order to have this cloud broker function to make it a reality. So we start with Ureva, distributed remote rendering, with Mandriva here, who's an OW2 member and who's exhibiting here for the migration of platforms, NextCD for the accounting and billing, Nuxeo for document management, and XWiki for application management. All these being OW2 members. Technically, so I'm drilling into the technology. I'm not going to show you any code today, so sorry about that, and no demo, but the demo is online. Technically, it relies on a whole architecture. So this is what I'm going to try to explain, which is the kind of architecture and the concept that we are developing at the moment. That's the overview of the whole architecture. It's a 4-quadrant or 4-step process, starting from the bottom left. The bottom left, with the SLAM, with its SLA management, is an interface that connects with the end user, and where the end user specifies its needs, whether technical, economic, SLA, etc., and other constraints. This interface produces what we call a manifest. A manifest is an XML document with a certain structure that I will develop in the next slide. And this manifest, which is the bill of charge, the bill for the customer, is passed to what we call the parser. And in the parser, we have the functionality that identifies all the modules in the needs in the manifest and applies all the billing and accounting constraints and SLA constraints on the modules. Very importantly, we identify what has to be invoiced and under which conditions. The parser then, with all these instructions, delivers what we call the plan. So the execution of manifest is the plan. And the plan includes a certain number of nodes, and the requirements are transferred to the broker engine. The broker engine, which you see on the top right, relies on a certain number of services. These services, we are developing them, but we're also inviting the community to extend the catalog of services that are available here. I apologize for the acronyms, but if you look there, you have the CUBAS. CUBAS stands for CompatibleOne Auditing, Billing, and Accounting System. The COES is CompatibleOne Elasticity Services for managing the scalability. COES is CompatibleOne Energy Efficiency Services, so we're targeting green computing here. CONETS for the network. EasyVM is the mechanism to automatically generate and deploy virtual machines. PaaS for Dev is the OSGI management environment for the system, and Unidata is the block data management system that is connected with EasyVM. Of course, there could be other services offered. Then, once the broker puts everything together, with connecting all the services, identifying those services, and we'll see how these services are identified, it puts together what we call the contract. And the contract is then submitted to providers who are able to address the needs of the user. And together, they provide what we call the service, or AO services. All this runs on backend services, the publisher that identifies which services, the mechanism for declaring and circulating the information about the services that are available. Course is for the security, it's all the security services. Commons is the repository of all the existing VMs and nodes and contracts that already existed, so that we don't reinvent the wheel. And with all this, we are gradually developing all this environment, and that's exactly the whole system that will be shown in November. Drilling down a little bit, the discretionary model, all the system is fully compliant with OCCI. All the mechanisms from OCCI are there. We are actually, it's based on very simple interface and protocol, so it's HTTP, REST, and OCCI, and period. We understand that we need to be scalable, and we don't have more sophistication than that. So what you see here is that OCCI defines an entity, which is described in terms of its resources, the links and mixing. So this is what OCCI defines. The resources are described in terms of network, compute, and storage, to which there are added storage and network links. We use that very high-level description ontology, if you like, that can allow us to describe virtually anything in cloud computing. So we take this, starting with the user and their accounts and the manifest, and all the user requirements are defined in terms of nodes. So a manifest is a collection of nodes, a node being a unit. This is our unit of, this is what we manage, technically. The node is described in terms of its infrastructure, its image, and its actions. The infrastructure is defined using the OCCI categories, network, compute, and storage. The image is described in terms of its executing platform, so the operating systems, and the set of packages that are to be deployed in order to deliver the expected application functionality. A node has also actions attributed to it to define some that take into consideration some constraints, the way it has to be monitored, the way it has to be configured, The actions also, for instance, explain typically how the nodes relate to each other within a manifest. And a node can also have a preference in terms of provider. We can describe that any provider will do, or we can, with the node, say that for this node, that provider has to be an OpenStack or an OpenNebula provider, or a provider within my boundaries, or within my region, or within my company. These describe how a node is handled. Then the all instances are that the manifest, when it's managed, gives rise to a plan. The plan is then inputted into the system with all the pricing and auditing and billing information. In the plan, you can have several contracts. The contract being what? Being the way we instantiate the nodes. And in a contract, you have all the addition of all the actions and attributes of the different nodes. You can have many contracts, and then that together will put together into one or several services that will eventually be delivered to the end user. Typically, we use the OCCI discovery mechanisms that for discovering services. So typically, what we have here is state 0. We expect providers to develop a very simple, this is in this case of an OpenStack proxy for their services that are published, identifying the publisher. Then when the user sets its requirements, the broker checks with the publisher the availability of the services. Then we get into the loop that we have identified with the contracts. The cloud provider provisioning the services, and the publisher with the constraints of the SLA and the auditing requirements checks that the instantiate the verification of the service. All this running on an OCCI and REST set of protocols. Very simply, it's exactly the same structure that would apply to an OpenNebula provider. And as you might expect, we are implementing this throughout several infrastructures. So we're discussing with Azure, we're discussing with CloudStack, we're discussing with all of them. The model is evolving. We've just issued version 2 that, for instance, automates the generation of virtual machines. This is totally automated now. And we have now the possibility to include nodes inside or manifests inside other manifests. So we have like a fractal way in order to manage more increased complexity. And typically, you could have one broker within a company brokering their company resources, and also interrelating with a broker outside. So to finish, the key components of the CompatibleOne that provides a provisioning mechanism that is also interoperable. We have CORD, which is called the CompatibleOne Resource Description Schema, ACORDS, Advanced Capabilities for CompatibleOne Resource Distribution Services, EasyVM, Virtual Machine Interoperability, Pass4Dev, which is NoCI runtime, and Unidata for data interoperability. We are totally standard. We think this is what open cloud, this is our best attempt at providing an open cloud project. And it's a totally open project where we can work together. Everything is online. The resources are there. I invite you to check the website, check these resources, and I also have a bunch of white papers and one-page descriptions if you're interested. Thank you very much.